Hi, today I will show you how to answer question number 2 regarding to kinematic of a rigid body. First of all, list down all the information given, which is omega AB equals to 6 rad per second, length AB which is 0.2 meter, and length BC which is 0.5 meter. The question asks us to find the instantaneous center of the bar BC and to find the velocity of the slider block C. But before we jump into the solution, we have to draw the FBD, which is free body diagram, and kinematic diagram. The FBD would be like this. Since the question haven't give anything information about the box, so we can neglect about the box. For question A, the question asks to locate the instantaneous center of the bar BC. Since point C is moved to the left due to the omega present at the bar AB, so it causes link AB to rotate anticlockwise at point A. The instantaneous center of velocity for BC is located at the intersection of the line segment drawn perpendicular to VB and VC. Note that VB is perpendicular to link AB. Therefore, we can see that the IC is located along the extension of the link AB. So, we have answered the question A. Now, let's move on to question B. So, to answer question B, which is to find the velocity of C, velocity of block C, how to find that? First of all, we can use the formula of VB equals to omega EB times with RB related to IC. But before that, how we can find the distance here? We can use the cosine rule. See? Equals to CIC over sine 45 equals to BC over sine 45. So, we have to find the distance of the line B to IC, which is B IC equals to sine 80 equals to BC equals to sine 45, which is BIC equals to 0.5 over sine 45 times with sine 80. So we will obtain the answer is 0.6964 meters. So the formula is from the rigid body, so we just take all the information and put it into the formula. So we will get the velocity for B is 4.1784 meter per second. Why we must find the velocity for B? This because the velocity for VC is related to the velocity of VB because the omega presence here. So once the bar AB rotating, just the velocity C will occur. So now let's move on to find the VC, which is we can use the same formula, which is BC times with RC IC. How to find the distance of CRC? We can use the cosine rule too. So we will get CIC over sine 55 equals to BC sine 45. So CIC is equal to 0.5 sine 45 times with sine 55. So we will get the distance for CIC is 0.5792 meters. We have got this. But for omega BC, how to find omega BC? To find omega BC, we can use the formula VB equals to omega VBC times with RBC. So to find this, we make it as the subject. So omega BC is equal to velocity B is over RBC, which is we will get 4.1784 over 0.5. So we will get 8.3568 rad per second. So we have the information of omega BC, we have the information about RC related to IC, so we just put it into the formula, which is VC equals to 8.3568 times with 0.5792, and we will get the velocity for C is 4.8403 meter per second. Thank you for listening.
Okay guys, today I'm going to show one question from chapter 17, which is Partner kinematic of a rigid body, force and acceleration, equation of motion. So from the question given, mass for G2 is 50 kilogram. Mass for G1 is 30 kilogram. And deceleration is 5 meter per second cube. 5 meter per second square. So step 1, draw free body diagram and kinematic diagram for us to know the flow of motion. Label G1 and G2. Point A and point B, and normal force point A and normal force point B. Given mass for G2 is 50 kilograms, so we can calculate the W, or the force is mass times gravity, so 50 times 9.81. Same goes to G1. Mass for G1 is 30 kilogram times with 9.81. Point A and point B. From the question, the bicycle going to the left, so the flow for G1 and G2 is going to the left. Force equal to mass times acceleration. Given mass for G2 and acceleration is -5, so G2 is 50 times -5 and G1 is 30 times -5. Step 2, we are using the equation of motion to solve the problem. From point B, we can find the moment at point B is equal to summation of moment K at point B. K is the Y component. From moment, we can calculate force times distance, and from force, we can calculate the mass times acceleration. From the diagram, we have 4 components. First is G1, 30 times 9.81 times with 0.6. Plus with 5th G2, which is 50 times 9.81 times with 0.4. Minus normal force at point A times with 0.6 plus 0.4. From the kinematic diagram, given mass and acceleration 50 times with negative 5 times with the y component distance from G2, it is 1.25 meter, plus with 30 times with 0.5, and the distance is 0.4. Solve the equation. Normal force at point A is 745.28 Newton, which is force at front wheel. Now we have to find the rear wheel, which is normal force at point B. Summation force y component is equal to mass times acceleration. From the diagram, we have 4 force in y component, and A and B, G1 and G2. Solve the equation. We get normal force at point B is 39.52 Newton, which is rear wheel force. That's it for all. Thank you.